here to just share. What do you need to know? That's
There you go. So I have a lot of people asking me questions. They're wanting to know how to make these things. The Keshe Spaceship Institute, let's just say really quickly first, Mr. Keshe is a very amazing physicist who is bringing forth a new science of energy in our world. And Nassim Haramein tells us there's enough energy in 1 cubic foot of space to run everything on Earth for a year. So how is that even possible? It kind of takes a new orientation of our thinking to even get how that can be possible. Do you want to say something about that, JC?
well, I'd like to clarify a little bit. With Nassim's mathematics, there's enough, and there's an infinite amount of energy in a cubic millimeter of space. So yeah, the energy is utterly unlimited. Space is not empty. It's absolutely full. We just can't perceive what it's full of.
Right. I notice when I'm out teaching workshops and I bring up the idea of free energy, and people in the audience will say, oh, energy can't be free. We have to pay for our energy. But what we're really trying to do is introduce this new concept, not that just energy can be free, but that energy is free, that there is this free energy flowing around us. And something happened on planet Earth a long time ago of telling us that the only way we could get energy was by burning ancient fossil fuels, by polluting our atmosphere, by running the type of electricity we do, which we end up having to pay for. But what is being introduced right now is an entirely new concept of relating to the energy that is flowing around us all the time. Would you say that's correct?
Pretty much. What we're paying for is the conversion of energy.
Okay.
Um, Energy's free. We get it from the sun. We get it from the universe. It's all around us. It's passing through us. We're living in a sea of energy, just like the fish live in the water in the ocean. It's everywhere. It's in
Wow.
us. It's around us. It's our thoughts. Everything. When people think of energy, they think of electricity, which is a very, very tiny little spectrum of the energetic field. And if you look at in conventional physics, if you look at what is called the electromagnetic spectrum, which goes basically from 0 cycles per second or DC to gamma rays, it's a little sliver of the available energy out there because just like a number line, it doesn't end at a certain point. It just keeps on going. You can have a frequency that is infinitely fast. I mean, it doesn't have to be 12 gigahertz or 12 billion cycles per second. It could be quadrillions or quintillions of cycles per second. And we're not even prepared to perceive frequencies of that state. What we're dealing with in the plasma state is the entire spectrum.
So what I'm fond of saying with plasma energy, this is it's almost, wouldn't you say it's really a new science that is teaching us how to interrelate with this energy that's flowing all around us and how to
Uh, I don't know if I would
utilize
call
it?
it new. I wouldn't call it new. I would call it the original science.
Okay,
This is the energy that the ancients tapped into.
nice.
They didn't deal with electricity.
Mm,
They dealt directly with
I'm,
plasma.
I'm getting goosebumps.
It's we're actually we're breaking through the boundaries that were created in people's thinking and in their interaction with energies, the boundaries that limit us to this little teeny tiny spectrum of energy. And we're breaking
Right,
through those boundaries and we're accessing the entirety of the energy fields that are around us now.
right.
Uh,
You know,
and
go ahead, sorry.
it's no, it's the that energy field is infinite. It will never go away. You can never use it up, because energy can't be created or destroyed. It can only be changed in form,
Right,
which uh, uh, when you have an infinite amount of energy, you don't need any more. I mean,
right.
you know, get another 10% over an infinite amount of energy. It doesn't make any sense. You'll never use it up. You'll never have too little. The only reason you would have too little energy for a purpose is your conversion process isn't working properly.
So this is one of the really key teachings in my book, 21st Century Superhuman, that we are beginning to learn that our thoughts create our reality, that there is abundant source energy flowing all the time that we can create from. And we are creating all the time. In the past, a lot of it has been unconscious, unless you go back to the ancients who were very advanced in different civilizations, for instance, ancient Egypt, etc., where they understood this. But that's what this evolutionary leap that we're in, that the Mayans predicted, this shift of the ages, is about us grasping these things. And it is going to catapult us into what I like to call a new earth society, which is capable of operating in peace and love, because we're not struggling to own things or to have, because we begin to recognize that our resources are endless. There is no limit to what we can have or what we can create. So I think this science, this plasma technology, is part of implementing our understanding of this from a technical aspect.
One of the things that's coming out, Mr. Keshe has brought this out a number of times, and I understood it as soon as I saw the technology, as soon as I saw what he was doing with his with the dynamic reactors, the balls that are spinning, and the first
Right.
ones he was making, was I realized he had the ability to take an atom apart and put it back together any way he wanted.
Wow.
So we are no longer limited to, if we need carbon, go make carbon. We're not, if we need gold, you got to go dig it up. We don't have to do that anymore. We can take the energy, the source energy, which is everything, it's potential everything,
Right.
and put it into a condition where it will manifest whatever it is we need. Now, having the little box on your counter and you push the button and say hamburger and a hamburger pops out, we're a little ways away from that. But the potential is there. Right now, at this moment, today, right now, we can make the energy of the food so you don't have to actually eat. All
That
you
is
need to be is
amazing.
within this energy field,
Right.
and your body will absorb it.
Yeah.
Because if you think about well, for food specifically, if you think about the food process, we have energy coming in from the sun, coming in from the universe, hitting the planet. The plants absorb it, make more plant, make fruit, whatever, out of that energy.
Right.
Along with some stored energy that came in 20 million years ago that's in the soil, right? Animals eat that, we eat the animals, we convert it back into energy, use it for our bodies, expel what we don't need. Now, why not eliminate the middleman? Just get the energy that you can absorb and use directly. It came out, I'm not sure if it was the last workshop or the one prior to that, but it's very recent. Mr. Keshe mentioned that the majority of the energy we use to exist day to day, we get from the environment, not from the food we eat. Which I was thinking about this when I was at the pool discussing this with some people yesterday, and it came to mind that this is probably why we can eat this garbage food, which has virtually no nutritional value in it whatsoever, and still live 60 years.
Right.
Because the food doesn't matter. The
Right.
food is I like to eat, so I'm not really
Right.
going to give up food, but
Right.
it's not necessary.
Right.
I'm not talking about breatharianism. That
Mm.
is a very narrow interpretation of this.
Right.
What I'm looking at is looking at the system in its totality, where all the energy that we live, that we eat, or that we used to live, that we grow with, that we replace ourselves with, it all comes from the sun and the universe coming through the atmosphere, being adjusted and created through that. Why not just do it ourselves? And that's
Right.
what we're learning now, is we can do that.
Right.
And it's
Do we
really
want to
not
get
very
into
difficult.
talking about GaNS a little bit and this, what that is, or
Sure, we can start. Actually, I should probably start with a few definitions, just
let's
so
just,
that
can
everybody.
I interrupt you just a second before you go that direction? And I just like to say about Mr. Keshe that he's kind of being compared to Einstein as far as, and I know that some things he's even surpassing Einstein's theories or formulas with what he is kind of grounding into this dimension right now. But you look at them, they almost look like brothers from a different mother. And there's a lot of, so we're looking at that level of physics, and it's kind of the new physics, so it's maybe not as accepted by the traditional community, but through something that we call open source that was started this last year, or last couple of years, by the I think Ohio University professors who started 3D printing and decided the best way to keep these technologies going was by getting it out to everybody in the world and letting people begin to play with the technology. That's what's being done with the Keshe technology right now. But one of the things that we're working on through these videos that we're going to do is just to explain some of the basic principles. I have people asking me questions all the time, and we need some elementary steps to get us into our understanding of this so we can really grasp what's going on, because there's been an awesome amount of information Mr. Keshe has been teaching the last 2 years to a group of people who are more technical at the Spaceship Institute, and really getting this information out. And then in the last few weeks, there was a public course that happened that I watched the whole thing of, and I was waking up at 4 or 5 in the morning to listen to these things, and there were a couple of them a day, a couple of sessions a day, and they were awesome. I was like sitting in a classroom with this really brilliant physicist, and people would complain that he didn't have good teaching skills, and I was thinking, man, you're getting to sit in a room with one of the most brilliant physicists on the planet. Just enjoy that he is talking to you and letting you in on. One of the things Tony Robbins taught us is when we duplicate the mental syntax and the physiology of someone who has accessed a paranormal part of their brain, we access that same part of our brain. So it's why people sit at the feet of a master. It's why we would go to the Keshe Spaceship Institute and learn from Mr. Keshe and those who are learning from him, because it helps us access the part of our brain that can understand this new science. So I just wanted to introduce that about him a little bit, because I think a lot of people have some really vague idea of who he is. Is there anything you'd like to add to that? I know you've been.
Well, other than I really like his teaching style, because he makes you think. He doesn't give you the fish, he teaches you how to fish. He's
Very
teaching you
nice.
how to look at the systems in a whole new way.
Right.
And people who have a problem with the way he teaches, don't step back and go, well, he's giving me information, how can that apply to what I know, rather than going, well, he's not giving me what I need to know.
Right.
He is giving you what you need to know, because you need to learn to see it in a different way.
Right.
And that's the most amazing part of this whole process, is watching myself go through this adjustment period,
Right.
where I'm letting go of the, what's the word I'm looking for,
Kind of the
I'll
old
just
model.
I'll just call it concrete physics,
Mm-hmm.
where everything's a number, everything's a formula, it's all, you can write it down,
Right.
it's all in there, in your face, right in front of you. You can put it on a blackboard and some kid can copy it down and memorize it. What we're coming into now is what I call intuitive physics, where there are no measurements, there are no numbers involved. Plasma, you can't measure plasma. There's no way to do it. It's everywhere, it's everything.
Right.
So, I use the analogy of weighing a glass of water at the bottom of the ocean.
Right.
Intuitively, yeah, okay, it's got mass, there's going to be a weight to it, but how are you going to do it? You
Right.
can't separate the water that's in the glass from the water of its surroundings.
Nice
And
analogy.
the plasma is exactly the same way. Another real big argument. Ruff, go lay down. My dog is chewing on my feet.
We can say hi to him. I love your dogs.
Yeah, well, I got a heater and stuff on my lap and everything. I
Okay.
can't really have him jump up right now.
Okay.
So,
No
but
worries.
he's a big 100-pound Bernese, and he's a real sweetheart. He
Yeah.
loves sleeping on my chest. Um, where was I going with this now?
Just with grasping this new technology, the
Yeah,
water glass in the ocean, and how to.
yeah. It's just, oh, I remember where I was going. A lot of people, a lot of physicists, they will bring up the third law of thermodynamics. You can't get more energy out than in. But they fail to read the rest of the sentence, which says in a closed system. A
Mm,
closed system is nothing more than a thought process. It doesn't exist.
wow. That is
Okay.
that's really, 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 really cool. Yeah. And
Well,
expands your
it's
thinking.
absolutely true.
Yeah, it's very cool.
Well, yes, it's absolutely true. And I completely agree with it. In a closed system, you can't get more energy out than in. In the system that we live in is an open system. You can't take an atom out of reality and separate it from all the other atoms around it.
Right.
We can't do it. It's not possible. So that atom is going to be interacting with everything around it at all times. So we're just not looking at where all of the energy is coming from. So this isn't over unity. This isn't spooky science. This is real basic fundamental physics when you look at the totality of the system you're working with. I mean,
I
there is essentially no separation. We're what, probably about 8,000 miles apart. Well, maybe 6,000 miles apart, but there's really no separation. There is a connection, a physical, measurable connection from the end of my nose to the end of your nose right
right.
now.
Yep.
And it's not woo-woo science. It's not some spiritual weirdness. It's actually a physical connection. There's an atom attached to my nose, which is attached to another atom, and so on down the line. We're attached to everything. There is no closed system. So, going on, let's look at some definitions that
Okay.
everybody understands, but we're going to expand these definitions a little bit to encompass a little bit larger picture. Everybody knows about the three states of matter: solid, liquid, and gas. Okay, solid is like ice. I'll use water as an example for this because it's fairly easy to understand how that works. Solid water is ice. The structure of its fields, which are we call atoms or molecules, are pretty tightly packed. Now, water has a little bit of a weirdness. When it freezes, it actually expands and becomes less massive, but we're not going to worry about that. Just for the analogy, when you solidify an object, you're packing the molecules, you're packing its structure down quite tightly. Some things, you get a nice uniform, even crystalline structure. Some are pretty chaotic, but it's all basically the same. If you look at the atomic structure, the atoms of what it's made of, if you think of them as little balls, those little balls are going to be packed down, squeezed really tight, really hard and solid, and packed tightly together, relatively tightly together. If you take a diamond, blow it up so the carbon atom that's in the diamond is the size of a grapefruit, the next atom is 600 yards away. So it's relative, okay? When you convert that into a liquid, you're expanding those molecules a little bit. They're not quite as hard and solid little balls as they used to be, and there's a little more space between them. So they're the fields that they're interacting with that are holding it all together are kind of a little bit looser and fluid, and they can kind of flow a little bit and move around each other. When you move into a gas, then again, they get a little bit bigger, a little bit fluffier, a little more space around them, and they can flow even more freely. Now we have added with this new understanding, we've added three more states. We've
Wow.
added nano, GaNS, and plasma.
Mm,
Now the nano state The easiest way to understand this is particularly when we're dealing with the copper, because we're pretty much all dealing with a nano-coated copper when we're
Right.
dealing with these devices. So I'll use the copper in this analogy. If you were to take a plate of copper, I don't have one handy right now, but and you look right down really close to it at the structure of that copper itself, what you would see would be a whole bunch of these little balls all aligned in nice, neat little order in a crystalline structure that makes up this metal. When we nano coat this, what we're doing in reality is taking the upper layers, 50 to 60,000 of them, but the upper layers will only deal with one layer at this time. And we're taking that top surface atom, lifting it away from the surface a little bit so it's kind of like a gas, and we're allowing the structure of that atom to pop like popcorn. So it's this big, puffy field, and it's just barely sitting on the surface. It's still attached to the surface, but it's just sitting there. We do this 50, 60,000 layers deep with our coating, and that creates a tunnel along that surface that instead of having all of the particles really tight together, they're big and puffy and there's lots of space between them. So the fields, the energy between these is very weak or relatively weak, which allows other energies to just flow through it very, very simply and very easily.
Nice.
That is essentially nano coating. You're taking the surface and you're popping it like popcorn, making lots of space within the structure of that surface. GaNS is the next step past that. You take that popcorn that you created on the surface and you release it from the surface. And it becomes even bigger, larger field, and it's just loose. It's just floating around and it's being happy and it's interacting with all the other stuff, but it's not trying to attach to anything, because at that point, when you pop it up like popcorn, it's a stable system. So it doesn't really want to interact with anything else. It just emits its energy really, really happily. Plasma is when you take that and you blow it up even bigger, so there's no more perceivable matter. Because matter, whether it's a strawberry or your foot or a shoe or a car or a gas or water, it's only a perception of fields. When you squash these things down and make them hard little balls, it creates something called a Coulomb barrier, which is another term is an event horizon. And it's that event horizon that we actually perceive as matter.
Oh
It's
my
still
God.
an it's still an energy field.
Awesome explanation. I'm getting total chills. Because, because I say our thought literally coalesces matter and events into form. And we're just at the
Yeah.
baby stage of understanding that.
Yes.
I play with it every day, and I have since I wrote my book, for the last few years, and I'm still figuring out how that all really works. But this is the beginning of us
Yes.
perceiving ourselves in a completely new way. But I love that the edge of the matter is the event horizon. That is very
Well,
cool.
the edge of the fields
The fields. Okay,
creates what we perceive as matter,
great.
because the matter doesn't exist. I mean,
Right.
even Einstein's equations, E equals mc squared, is not really correct, but it suggests that matter and energy are the same thing. The only difference is the speed. Whether the speed is it's spinning, vibrating back and forth, or shooting through space, the speed doesn't matter. But instead of what we're learning now, instead of speed, it's the strength of the fields.
I'm getting the
Okay.
idea that we should call this video Weird Science.
Well, it this all ties in with what we're going to be doing in a little while, and that is
Right.
is actually creating a device which absorbs fields, absorbs the energy, not only the energy that you are creating with your own thoughts, with your own intentions, but also ambient energy from around the device. I don't know how far it penetrates. It could go 10 million miles. I don't know.
Right.
Um, chances are, if you do create a device which is what I would call an energy sink, where the
Right,
energy wants to go into,
right,
everything's going to move that way
right,
a little bit. It's like think about the ocean. If you take a glass of water out of the ocean, the entire ocean moves to fill the hole you just created.
right,
So the energy field that's around us, that makes up the universe, that makes up everything, is going to react very similar to that. So if you create a sink of energy, just like the one of these pain pens is, as it's absorbing the energy and directing it, all the energy around it's going to move towards it and continually fill it. Um, Now, I should apologize. I did make a slight error just a minute ago. Uh, you are adding energy to the pen with your own thoughts and intentions, but more than that, your thoughts and intentions are, how do I describe this? Are creating a specific color to the energy.
mm, interesting.
Uh, it's not specifically a color. I'm using that as an analogy just because I don't
Right,
have the right word for it.
right,
So you're getting broadband energy coming in that's absolutely everything. And then with your thoughts and your intentions with the device, you are filtering that energy
right,
for a specific purpose.
right,
And that's what these devices are. One of the things that, as soon as I made my first one, I'm looking at this, I'm going, wait a minute, this isn't just for healing. This is an intent laser.
nice. I like
And
that.
all of the people that I've given these devices to, and I've taught to use them, I've suggested try them for everything. Try to put a specific flavor in a glass of water with it, or move a ping pong ball, or project a thought into an animal, right? Anything you can think of that would be in the realm of directed energy, try it.
Right, I
Because we
like that.
don't know the limits of these devices. We
Right.
have no idea how far we can take this until we play with it.
Right. Let's go back just and review. So you were giving us definitions. So we had nano, which is going to be, we're going to talk about that as a coding to these devices, and we'll talk about that more later. And we'll
Yep.
have probably the instruction video for how to do that under this video. We're not going to get into how to do it. I mean, we may talk about it, but just in generalities. And then we have GaNs. And was there a third level that you just explained that
Well, the plasma,
the plasma, right? Okay.
which is which
Again, the
is
plasma,
the source energy.
the source energy. Okay.
Okay, so we're going from this. If you go backwards from plasma, GaNs, nano, gas, liquid, solid, you're going from the source energy to the final result of the compaction process.
Right.
Each layer down is more dense, has a stronger Coulomb barrier, and is perceived more strongly as matter.
How do you spell that colon barrier?
Coulomb, I believe it
Oh,
is.
colon. Interesting. And so, one of the things I'd like to bring up at this point is the torus field, because the torus field is something that is one of the symbols or the ideas of this endless energy flowing. And it looks like a donut shaped field where energy is just eternally flowing. And I'll go back to Nassim Haramein. You may have other input on this, but he says that our universe is basically torus field within torus field within torus field. The flower of life, which is the really beautiful sacred geometry image, which is actually on the back of my book, along with the Star of David, when those are put into third dimensional view, the flower of life becomes the torus field. The Star of David becomes the Merkaba, which is basically our energy field, how we move through those torus fields. But at about 21 days in uterus, once a baby has been formed, about 21 days, a torus field begins operating at the location of the heart. And no one understands exactly how that gets there. The thought among those scientists who understand things at this level at this point. Nassim Haramein says, shh, don't tell anybody, but what starts it is love, you know? So what is this endless flow of energy that we can create from? And I just toss out a second, because we've spent what we're in this world right now where we've got all this disclosure going on, we've got disruptions going on. We're watching a civilization that has been kind of established outside of love, with a lot of, you know, more for me, you know, hoarding and selfishness, that has not recognized that we're living in an endless energy field that is willing to give to us anything that we want at any time. So I think what we're doing is shifting our consciousness on so many levels. You know, it's how we are a living being, how we live in this field, what we can create from it. And this science is so beautiful, because it's Mr. Keshe is bringing forth, and those who are working with him, these tangible ways that we can begin to see this whole system harnessed for our well-being. And his bottom line, again, is about peace. It's about living as a peaceful civilization on the planet. So I really appreciate that that's part of his, you know, how he's founding this science.
Yeah, looking at the torus structure, what we're seeing with that is the organizational aspect of the energetic field, which creates something. We know that every field, or you know, every system, let me put it that way, has two sides. It has one side that radiates or expansives, and one that is contractive. Okay, you can't have a system which only radiates.
Interesting.
It just doesn't work.
Right.
Okay, everything, black hole, the sun, you, everything has both sides of the equation, both an expansive side and a contractive side. Nassim describes them as expansive and contractive, or radiating and contractive sides. Mr. Keshe describes it as the magnetical and the gravitational sides.
Right. Oh,
It's the
nice. Yeah.
same concept. Okay,
Nice.
the magnetical is the expansive side, the gravitational is the contractive side of the equation.
That's really helpful. Yes.
When these two organize into a coherent system, they create a flow of the torus field.
Nice.
So from, it's the viewpoint is relative. So I'm going to use top and bottom very, very loosely. The top of the torus is the radiative side. All of the energy is coming out, and since it's the same energy that the system is looking for, because it's the energy it's made of, that energy curls back and flows back into itself, which gives you the contractive side. Now, it's entirely possible and probably pretty likely that some of the energy that's radiating out goes out into the environment, and some of the environmental energy is drawn into the contractive side. But that's what creates that torus structure, is the flow of the energy from the one pole to the other pole, or from the contractive to the, or from the radiative to the contractive side. All the systems that we look at, all of the systems that these people are describing, they're all the same systems. They're just describing them in different terms, because that's how they understand them. And so what I'm seeing with Nassim is a direct correlation with what Mehran Keshe is talking about. They're just using different viewpoints. It's the same stuff.
I love it. And this is pretty heady. I mean, I can hear the people who are writing and asking me questions, even though we're explaining it in a very simple way. It's still a lot for people to kind of grasp and go, wow, I can get this, I can absorb it. And we need to be patient with ourselves, because we're asking our brain cells to actually expand. You know, scientists say we only use 10% of our brain, because we've only probably been paying attention to 10% of our existence. So this means expanding into greater use of our mind, allowing our brain, our mind to expand and comprehend in additional ways. And so I say just be patient with yourself, listen to this a few times, repeat the process so you can start taking it in, because that's what I've done. JC, I know that's what you've done. We've both had, you've had a lot of exposure. I've had not as much as you, but you know, at first you kind of go, oh my God, am I ever going to understand this? And then it starts clicking and making sense. So
Yeah, one of the things I've been fielding questions about pretty much on a weekly basis is, you know, what is this expansion? What do you mean by expansion? What are you talking about? Expand my mind? And what it really boils down to is getting a larger point of view.
nice.
When you're laying on your face on the ground looking at the sidewalk, all you see is a rough gray surface. That is your reality at that moment. That is what a sidewalk is this rough gray surface. And it's from your point of view, it's everything. If you stand up, you realize, well, wait a minute, it's not everything. It's a little thin strip that goes that way. And it goes that way too, goes behind me. And it doesn't look quite so rough. It's got kind of a shine to it. If you were to step back again, go up to the top of a building and look, again, you're going to have another point of view,
Right.
another point of awareness of your surroundings, of your environment or your reality. And you're going to realize that that sidewalk is actually really, really tiny
Right.
compared to everything else. Again, take another step back. You're on an airplane at 60,000 feet and you look down, you don't even see the sidewalk anymore. You see the environment around it. So the sidewalk suddenly becomes really unimportant in the
Nice.
larger picture.
Nice.
This is what we're talking about. This is the ascension. This is the mind expansion. This is exactly what we're all talking about.
Nice. I like that.
Very simple terms. You're going to take a step back and you're going to look at a larger picture.
Nice. That's really a nice description. Well, why don't we do playtime for a little bit and do something practical, which we both really enjoy too, and you're really good at. You're a tool and die man, right? So you understand how to do all this with tools and make it look really great. And I'm doing these little handheld things here at home. I've been playing with tools also, but I don't have those with me here. But I've been playing with making these healing pens just here by hand. And so I think let's each share. So we're going to talk about, I'm going to hold mine up and I think you have some there as well. I have these healing pens, which are a couple of these little devices that basically help us focalize energy, as you said, kind of an energy laser. And they're very cool. Mine aren't completely done. They are not nano coated yet, but I've just been playing with them, making them here at home. So we're going to play with making these. And I have people asking me all the time, how do you make those? I want to make one. And people are selling them for $100 from India. So you can buy yours, you know, but I don't know where that came from. But anyway, these are easy to make. It's easy to make them at home. I'm sure there will be all kinds of people making them that you can buy them if you don't want to. Ultimately, they end up encased in plastic. One person wrote me the other day and said, isn't it dangerous to be working with copper in your hands all the time? Because I had a friend who got an overload of copper and now she's really sick. But you know, a person might wear gloves if they felt they needed to. But I've been working with the copper in my hands and it seems fine. But why don't we just start kind of at the beginning, which copper wires we want to work with, where those come from, and then kind of go step by step into this process.
Okay. Well, as far as copper goes, you can get a couple of different kinds of copper wire. One is called magnet wire, and it's copper. It's very nice copper, but it's got a coating on it that's kind of like a shellac, and it's a very, very good insulation. And they use it for winding coils, for transformers, for battery chargers, motors, generators, that sort of thing. It's not suitable for what we're doing because it's really hard to get that coating off.
And what is that
And
called again?
it's called magnet wire.
Magnet wire. I
And
bought these
that's
little
what,
packages of wire at Home Depot. Would you say that's, let me switch back here so people can see. But these were just, I got 16 and 18 are what I'm working with here.
yeah. when you buy magnet wire, this is a little tiny spool of it.
Okay.
This is stuff I was using for an electronics project, but it's a very red color.
Okay.
Um, the it still looks like copper, but if you were to take it and take a little bit of sandpaper or a nail file, you can scratch it and you can see a color change. You can see a different color underneath it. This is specifically for electromagnet properties,
Okay.
and it's not suitable for what we're doing.
So it's called
So
magnet
if
wire. Is that right?
yes,
And we don't want to use
and
that.
you don't want to use it. It's
Okay.
really hard to work with.
Okay.
Because you have to get that coating off, and that coating is tough. I mean, you can burn it and still it doesn't come off. It's amazing stuff. So what I use is like regular house wire. If you were to go to home hardware or an electronic or electrician, not electronics, but an electrician, someone who wires houses, they will have house wire, which is like a 12-2 or a 14-2 or a 14-3. That's what they call. If you go to Home Depot and ask for 14-3 wire, what you're going to get is a round wire, a little bit smaller than your little finger, and inside of it you're going to have four pieces of wire. Um, Three will be coated with insulation like this one is, and one will be absolutely bare. This wire works really good. This is excellent stuff to use. You can also get the same thing. It's called a ground wire, and it's usually like a 6 gauge or a AWG 6, which is huge. It's like the size, almost the size of your thumb. Um, but that wire, it's the same grade, the same kind of wire as this. It's just there's 7 strands all twisted together, and you have to take it apart.
So let me say this, John, because like for me, what I mean, I had you coaching me, which was great. I mean, I could message you and say, hey JC, what about this? I went shopping at Home Depot or Ace Hardware and this is what I found, and you kind of kept directing me the right direction. But even for someone like you who's a little more educated in wire and different kinds of things, and I don't know, maybe men have a little more background in these things than women just because of having been exposed. Not necessarily, I don't want to make a
The
gross
women,
generalization, but
the women are doing this technology better than the men
okay,
right
so,
now.
but what I'm saying is anybody who's had exposure to wire technology is going to know a little better when they go shopping.
Yeah.
And even what you just explained to me, again, my brain starts going into overload, like, oh my God, okay. So maybe we'll list these things under the video. We'll make a little list of what kind of wire you would look for. Now, the two you just explained, you have to remove a plastic coating from those wires, right?
Yep. There's a plastic coating holding the 3 or 4 wires together, and then
Right,
there's also a plastic coating on the wire itself. And
right.
it's not really hard to take that coating off.
So you do it with a
I'm gonna
just with
I'm
a
gonna show
sharp
you how to
knife.
do it.
Okay.
Well, some of them, the North American wire, this coating is
Hmm.
really tough.
Okay.
In Europe, it's not quite so tough. They can just take a potato peeler or a vegetable peeler
Right.
and just strip it right off, and
Right.
it comes off ridiculously easy. In
And
North America, this stuff is tough.
what do you think about this stuff that I got? Because I'm
As
not,
long as it's not coated.
as long as it's not coated. Is there any way to tell if it's coated?
One of the easy ways to tell is to take a little piece of it and just leave it out in the environment.
Right.
If it starts to tarnish and
Hmm.
discolor, then it's not coated.
Oh,
If it stays bright and shiny, don't use it because it's
this
got something on it.
this might be coated then because I've had these out and they're still bright and shiny.
How long have they been out?
Oh, like I don't know, a couple of weeks.
Okay. Um, give you an example. Let me see.
And are you using 14? I know we're using 14 gauge for the power units and the car units. Are we also using 14 gauge for the healing pens? We lost your volume, JC.
How did
There
I
you,
get muted?
there you
I
go. I don't
bumped. I
know.
must have bumped something.
Boom, boom.
Um, You can use a heavier wire, you can use a finer wire. It depends on what you're doing. The
Right,
reason we're using 14 gauge for the power units is that it matches the wire in the load.
right,
So for the initial process, the initial conditioning of the system, you need to match the wiring.
right.
Once the system is conditioned, everything's a superconductor. The size doesn't matter. The wire can be the size of a hair and run an entire city.
Okay, so can we just take a sidestep before we go into this process and just talk a little bit about the units that I'm aware of that we've been kind of taught publicly now by the Keshe Institute to work on are the healing pens, and that's PEN, which is this energy focusing device, and a power unit, which can potentially run your home, put in kind of adapt to the wiring in your home and then pull in the kind of power that's going to take over feeding power to your home. And then some certain units that are for automobiles or cars, vehicles that help um, make those run better and use less gas, use less fuel.
Mhm.
And that's what I know of. Is there more that I'm not?
Well, there will be lots more.
Right. And then we have
Um,
the items that are made from GaNs, such as the pain pads and different kinds of things too. So,
yeah, well, you kind of need to know. One thing I didn't bring up that I wanted to was one of the things we use the GANs for is an energy source. Because the way I view it is nano is plasma that acts like, or matter that acts like plasma. GANs is plasma that acts like matter. Okay, so the
ooh,
GANs
I like
is
that.
concentrated plasma.
Right.
It's this energy that's readily available. It's easily freed, so we can access it really fast.
Right.
So we're using the plasma as an energy source or a storage for this energy.
Right.
Okay, that's why we put the GANs on the reactors. That's why we put the GANs on the paper towels to make your health pads. Because now I have concentrated energy on this surface that I can apply to whatever I need to apply it to.
Nice.
And it'll never go away. It'll never use up. Like it does, they do eventually degrade, and I've got mold growing on some of them. And when I used them on my dogs, particularly Rough, he had a condition on his back that it was like eczema times 20 that nothing would touch. I mean, coconut oil and olive oil and tea tree oil, all of the standard skin conditioning remedies that we use. Um, yeah, it softened it. It didn't stop it. It certainly didn't go away. And he struggled. I struggled for a year and a half with this, and my poor dog was almost nuts. um, I made some CO2 GANs, put it in a pad, put it on his butt. The first time it was about 15 seconds. Well, all three times was about 15 seconds each time.
Wow.
And they were about 3 or 4 days apart. Just he would come over and he has this little dance that he does that says, scratch my butt. And the first time I put the pad on, I just put it on there and held it there. I didn't move or anything. He immediately spun around, sniffed in the pad, and completely relaxed.
Wow.
Absolutely. It just melted right there.
Cool.
And after that, he does a different dance now when he comes over and he wants the pad rather than a scratch.
Nice.
His skin condition is gone.
Nice. I miss
Three,
my GANs. It's down in Florida. I'm up in Michigan right now. And to see family and teach a few workshops. And I'm missing my GANs.
Yeah. Another thing, just to go back to what we were discussing just a minute ago with the different kinds of devices, it occurs to me that what we're being taught, let me put that on do not disturb so it doesn't bleep anymore. There we go. What we're being taught with these devices is kind of like a training system for our systems, our subconscious and conscious systems, to once again recognize the plasma.
Nice.
Because
I
once
love it.
we're learning, especially with the pain pens, what we're learning with the pain pens is as soon as you learn how to use the pen, you don't need the pen anymore.
Nice. I
All
love
you need is
that.
a finger.
Nice.
Because we're retraining our systems to access this plasma directly.
So I
Because
should
we
be able to stick a
are,
paper towel in a Ziploc and just say there's GaNS in there and just use it. And
you should be able to just put your hand on whatever hurts and it goes away.
yeah, I'm working on it. I'm
Because
still,
we are GaNs.
yes,
Okay. Inside us is nano and GaNs. It's the same stuff
right.
we're working with outside.
I
It's
want
just,
instant results right now. I already know so
yeah.
much and I'm already practicing so much and still having to learn the journey.
Yeah. Well, we have been trained throughout our lives that if you want to do a job, you need a tool.
Mm-hmm.
So the universe is giving us a tool that allows us to do the job, but also teaches us we don't need the tool.
Right.
And there's a lot of people, particularly the folks in Philippines, that are working really, really strongly with the pain pens. They are beginning to realize I don't need the pen. All I need is
Right.
a finger.
And they are going into, they've got hospitals working with them, actually charting patients, and they go in and treat a patient with the pain pen and their vitals change instantly. Um, so
Yes.
yeah. And you think that
Yeah. It's
The Philippines is kind of the land of psychic surgeons and faith healers too. So there's probably already in their system, you know, their neurobiology. Oh, this can happen, you know.
that would be why the universe would have chosen that as the starting point.
Yes.
But even in Europe, we there was one report. I just caught the edge of this report, so I can't really confirm it, but I believe the source, and they have no reason to say otherwise. But a conventional oncologist used a pain pen and cured cancer with it.
Wow. Cool.
I'm going to be looking for the documentation for this because
Right.
this is very, very important. This
Yeah.
needs to come out in a big way. But
Right.
I think they're waiting until they have a few more. Because if
Hmm.
it's one occurrence, everybody's going, oh, well, he just went into remission, right?
Right.
But I, I've used them. I know what effect they have. And the effect is utterly profound if you allow it to happen. If you put the energy of doubt or let's see into it, it's not going to work very well.
And you're also experiencing that with having GANs in your house and not needing as much food, like the experience of, well, I'm going to eat because I like eating, but not even really being that hungry, right?
Yeah, I've got a little jar of GaNs sitting up on the cupboard up over there. I've got a mix of GaNs still in a syringe from an experiment I did earlier on, but it's not very much. It's maybe 75 milliliters, three
Hmm.
quarters of a cup, half a cup. And I noticed that while it's in my space, I just rarely actually get hungry anymore.
Right,
And when I do feel what I think is hunger, it's not the same.
right. So
It's
one,
it's completely
yeah, I'll just mention too, I'm working on our 21stcenturysuperhuman.com website, and we will have access to the power units, to GANs makers, you know, to have, you can set up your own and we'll teach how to do that, but you can also order one that's kind of pre-set up. It's how I learned initially. It was really helpful to have a unit that was already put together and I didn't have to go out and get the pieces and the things. And then I learned to add more to that. So we'll have some of those things available at our 21st Century Superhuman website really shortly here. I'm kind
Yeah,
of,
I saw the photo on Facebook of your copper scrubbies. They look amazing.
oh, good.
They turned out really nice. You're going to have really good results with those.
Cool. There, that whole project is like sidelined right this second. So down in Florida, I've got all the pieces down there. I actually took all my different kinds of GANs and put them in little jars and labeled them. And I don't know. I'm gonna have to like re-up. I'm gonna have to like set everything back up when I get back down there. So I will. I'm excited. I love doing this. It's like having a little science project in the garage or the backyard or wherever you can do it. And
Yeah.
Really
And
nice.
that's very, very important. That's very important when you're doing this work, is to have fun.
Yeah.
Enjoy what you're doing, because the energy that you're creating with that joy, you're putting into the devices. If you're
Yes.
frustrated or something doesn't work, set it down and walk away.
Right.
Don't keep going, because then you're going to put that frustration into the devices.
Yeah, we don't want to be doing that. It's time to be living our joy, and we're learning to do that. We're learning to let go of the old matrix, the old system. I love the movie The Matrix. I think many of us are stepping out of the matrix here. That works right in front of my black, doesn't it? But those are my little healing pens, and maybe I need to be using different wires, so I'm open to looking at that. This has been great for me to practice with, though, and I think just playing with it and getting yourself involved. Anybody who's watching will see in a few minutes how really quick and easy it is to make one of these. So I don't know, do you want to go ahead, John, and just
Yeah.
do
Let
a
let
little
me switch
demonstration?
cameras.
Okay.
Let me switch cameras and make sure that it's not showing anything that you guys don't want to look at.
Okay. And
It is,
as we
it
do
is a
this,
lap cam,
oh,
and
nice.
so you're looking at. I work in my easy chair.
Right.
I don't have enough room where I live to have a workbench, so this is my workbench, and it's just sitting on my lap.
Nice.
So we'll start with what a lot of people are having issues with, and that is getting the insulation off of this wire. Now this is just regular house wire. It's been taken apart, so I have a single wire. But if you look at the end right there, I don't know, can I get that close enough to see?
Yep, we can see that.
Right?
Mm-hmm.
Okay, this is 14 gauge wire,
Right.
and you need to get this white stuff off of here.
Right.
So one of the things, simple, easy, everybody's got them, is a pair of scissors.
And what do you call this, John? What is this wire? This is household
This is
wiring.
just 14 gauge solid copper. It
Okay.
comes from household wire. You got it running through all over your house.
Okay. And you think it's probably more, it's seeming to me now, since I bought these little packages, that the ones that have the coating on them are less likely, they're not going to be the magnetic ones, right? So,
Well, from a hobby store or a craft store, it's just
mhm,
going to be a shellac to keep it shiny,
got it.
right? If it's sitting out in the weather and it gets dull and kind of looks kind of dirty, then it's
Mhm.
not coated, because it's the oxygen is getting to the surface and altering the surface.
So buying it with the plastic on it is probably a really good way to buy it.
This is pretty much foolproof. Okay,
Okay.
you're going to get wire that works. If you go
That's
buy
helpful.
household wire, yeah, if you
This is
buy household
foolproof.
wire,
That's helpful.
you're going to get wire that works. Now,
Okay.
getting that insulation off can be a bit of a pain.
Okay.
There are specific tools. I had one here. I'm not sure where it went, but they look like a pair of pliers with a bunch, like on the handle
Right.
part,
Yep.
a
Yep.
bunch of
Yep.
holes.
Mm-hmm.
Like down in here,
Right.
down in here, there'd be a bunch of holes,
Mm-hmm.
and you just put that around the wire and give it a yank, and
Right.
those work really good. If you don't have those, or side cutters, or needle nose pliers with this little cutting edge on them,
Right.
which it takes a bit of practice to be able to use that so you don't cut through the wire.
Yes.
I would recommend, just for everybody who doesn't have that kind of experience, just use scissors.
Okay.
And you take the scissors and you put just a little bit of pressure and just turn.
Okay.
So you're cutting through the insulation, and then you see, like that,
Yep.
right? And then you just grab it and pull it off.
Cool.
And when you're doing the health pens, you're only working with, the length of your finger.
Right.
So you can do it in 2 or 3 steps. You don't have to try to take, 6 inches of insulation off at a time.
Right.
You can do it just with, little pieces that long,
Great.
right? And they come off really, really easily. Now, play with this. Sizes don't matter. Make them how you feel it works for you.
You were
If you
using
make
kind
one,
of in your diagram, you were using your finger as sort of a measurement stick for this, right?
well, I do that because right within your system, the length of your fingers, the length of joints in your hands, is embedded the golden ratio,
Right.
1.618.
Yep.
And I asked Mr. Keshe about it several months ago, and he didn't think that it really mattered. But what we're learning now is that, yeah, it does. The golden ratio makes a big difference in this.
Right.
Nines, 3 6s and nines.
Yeah.
The Fibonacci sequence, all of these things, all of the natural processes that we've come to learn do have a purpose within
Right.
this system. Okay, so once you have a length of wire done, like this one's a little bit longer than my finger, but I'm not going to worry about that because it really, I don't think it really matters.
Okay.
What we do notice from what we're seeing in the Philippines is that the longer the system, the deeper it's going to penetrate.
Interesting. Very good.
So if you have a really, really short one, it's good for skin or just below the skin. If you have one that's 4 or 5 inches long, it'll probably get right down into the organs.
Cool.
Okay. That may be the how narrow the field comes out, because
Right.
if you think of it like a hose, you can have a wide spray or you can have a little thin spray.
Right.
And I think that the length of this is, partly might determine the pattern that comes out
Right.
of the end of it. Okay, so once you have a piece out there, just snip it off, and I'll put this one aside. I have a PDF. I'll give the link to Carrie. She can put the link. I have a PDF to on a Dropbox, which is just a pictorial and a little written demonstration of exactly what I'm showing here right now.
Yep. It's really helpful too.
And I'll give Carrie the link for that, or she may still have the link. She
So
can just put it on the.
we'll put that under the video.
Okay. Now, first thing you want to do when you have this piece of wire, this could be 12 gauge, could be 14 gauge, could be a piece of pipe. It really doesn't matter. Okay. Whatever feels right to you. One end, take a little file. This is just a kind of an old beat up jackknife with a file on it. And you want to file a bit of a point on the end of this, on one end of this piece of wire, because otherwise it's going to be like a chisel shape. I don't know, that's probably not going
It's
to
a little
focus.
easier to see when you've got it back. Yeah, just working on it down there, we can see it okay.
Okay, but I just wanted to show when you snip it, if you look at it really close, it's kind of squashed into a chisel shape.
Right.
And both ends will be the same because you cut them both the same way. So concentrate on the corners and knock the corners off and kind of make a point on the end of this. It doesn't have to be dead sharp.
Nice.
But it should be fairly, like a partially used pencil.
Right.
Right. You can use sandpaper, you can use a grinder, anything like that. Nail files.
Yep.
A
When
metal
I
nail
was working
file.
on it, I went and found a toenail clipper in the bathroom and just used the file on it. That worked really well.
Yeah.
Talk
If you
about
have an actual real file, a proper file, then certainly use a real file.
right.
But most people, they're not going to have that around, but they probably will have a nail file or something like that handy.
Right.
And that works just fine. All you want to do is abrade it so that you have this little bit of a, I don't know, that's probably easier to see.
Yeah. Nice.
A little bit of a point on the end of that.
Right.
Okay. The other end, what you want to do is you want to look at that chisel shape and you want to grab it with needle nose pliers so that the chisel shape is in line with the jaws of the pliers. And you want to bend a nice little loop in the end of that wire and squeeze it down like that.
Nice.
Okay.
Yours is so
and then what I do, just because I'm fussy about this stuff, is I'll take this and I'll straighten that out just a little bit so it looks nice.
Cool.
Okay.
I had to struggle with that a little more, but I enjoyed doing, your demonstration is really helpful.
I've been doing this since I was a little kid. So, 40 some odd years of doing it, you learn pretty fast. Now, what this does, what have I got for a pointer that I can use? I guess I can probably use this. When the energy gets into this wire, it wants to flow along the wire. So if you have both ends just empty, the energy is going to be squirting out both ends of this wire. So to minimize that, we put this loop on there so any energy that comes out of the end of that wire is directed back into the wire. which makes this directional. Everything's going that way at this point.
Nice. That's really well
Okay.
said. Yep.
So once you know get it straightened out so that it's reasonably straight. This one isn't perfect, but that's okay. It doesn't have to be. That's the wonderful thing about this technology, is that you can totally screw up and it still works.
Yeah.
Which tells me there's really no, you can't really screw it up. But that's the core of the pin. Now you can stop there if you wish and nano coat this and it will work. If you want to
Just
make
use
it,
that by itself.
and just use this by itself, it's
Wow.
very simple, very rudimentary. If you're stuck in the bush, you have some problems, you're out camping, if you can find a little piece of solid copper wire and scavenge it from your truck or whatever, you can make a pin that will function.
Right. And the kind of popularized or sort of like approved of method of making the nano coating is with lye, and we will show that. We'll share the video of that. But if you were out in the woods and you were just carrying a little copper wire with you and you could make a campfire, you could literally nano coat this by heating it in the campfire, correct?
Yes, yes.
And so,
And what came out in the last workshop is specifically with the maggrav power systems, the fire method of coating is actually more efficient, it's better for the system than
wow.
the caustic. The caustic coating was the first example of it. Then we found out we can do it by fire. We're realizing the fire coating works better for certain things.
And are you in the fire coating? Are you literally building a fire, or are you? I know people were using little torches, right?
Yeah, people have used propane torches. They've used butane, which is like a cigarette lighter.
Mm-hmm.
Um, Campfires, barbecues, electric stoves, gas stoves,
And
and they all seem to work.
now
But
when you're
getting the
nano
temperature just right,
sorry, go ahead.
it's very important. Getting the temperature just right is critical. It's an art. Believe me, it is an art. I've done heat treating for a lot of years. I've heat treated a lot of steel and hardened steel and annealed steel and annealed brass, annealed copper. Worked a lot with the heat treating, and it's not something that every single one can do because it's a bit of an art form. And getting the temperature just right is vital. If you get it too hot, your coating just falls off.
So
There's you got to watch for color change, and there'll be more information come out for everybody. And I think eventually most people are going to be able to do this successfully.
right.
But right now, if you really want to do the fire coating, expect it to fail a number of times before you get it right.
So maybe we'll write up a little paragraph on that and put it under this video, along with the video on how to nano coat with the caustic, and give people some options so they can experiment.
Yeah, I can do that. Yeah. So anyway, there's the core of the pen. That's your basic system. Very simple. It's just a piece of wire with a loop on one end, and again, you can nano coat that and use it as it is. If you're stuck, if you want more power, then we start adding things to it. And
And
one of the
making
things
mine
we're gonna,
along with you.
yep, yep, that's fine. And again, the geometry of this loop, I don't think it really matters. The point is, any energy that's going to leak out of the end of that piece of wire, you want to direct it back to the wire. So you could have a small loop, a big loop. It could be a teardrop shape like mine, or a circle, or maybe it goes around 3 times. I don't think it really matters. Try it and see. That's all I can say.
Good.
Is experiment. We're looking for the limits of this now,
Yeah. And
and we just don't.
the great thing that's
We
going
just
on with open sourcing and sharing it with so many people is people are learning and experimenting around the world and coming up with a broader maybe form of expression, kind of. But
yes.
it's good to follow the basic instructions to start with.
Oh yeah. First time around, do it right. Follow the instructions as best you can. Try not to add complexity. or different things into the system until you know what they're going to do. And if you're going to change, I just brought this up in a Skype chat earlier today. If you're going to make a change for a specific reason, make one change. Follow the instructions, but add one thing to it, and then see what that does. If that gives you the results you're looking for, awesome. Make one more change, but don't just go in and change a whole bunch of things and then come and yell at people like me going, well, you told me and it didn't work, and because you didn't do what you were supposed to be doing.
Right. Yeah.
And there's like experiment, discover stuff. That's awesome. Do it. But when you're working with a system that we already know one way that works, start with the one way that works, make one that's functional for you, and then add one bit of complexity at a time.
Right.
Instead of changing the whole system and then freaking out because it doesn't work.
I agree, because I'm in these streams of conversation, the Skype rooms and everything, where I have people coming back and asking questions every day, and because they're not following the basic instructions. So that's one reason we're putting this video out too, is to give, here's a basic instruction for how this has been shown to work. And again, start with that. I agree.
Yeah. Here's a starting point. If you want to adjust, make your adjustments slowly and methodically. Don't change everything all at once, because then you won't know what change did what.
Right.
Okay. So the next part is the fun part. Now we're actually going to be winding coils. Now there's a whole bunch of different ways to do this. My system, the way I do it, is really efficient. It's really fast, but it's also a production method because I'm a tool maker. That's what I do. For someone like Carrie, I just suggested get a screwdriver, get a pencil, get something that fits.
Right.
But I'll explain.
I have those here, and I'll demonstrate my little homemade method, but you go ahead and do yours, because yours is.
Yeah, I'll explain what I mean about something that fits. Okay, first of all, I'm going to be making, with this one, I'm going to be making a 2-coil system. So I have a magnetical coil, a gravitational coil, and then the direction pin inside. This makes what I understand to be the broadest band, or the most versatile pen you can make. You can make a single pin, you can make a single coil, you can make 15 coils if you want.
And so all of these systems have 2 coils, or one inside of the other. And is it the magnetical is on the inside and the gravitational is on the outside, or the other way around?
No, think about it. The gravitational is the collapsing
side, right?
That's right. The gravitational is the collapsing side of the equation.
Collapsing side, yep. And then the magnetical is the expanding side. Cool. That makes sense to me for the first time. I love it.
Okay.
There's a rationale to those 2 coils.
Yes. They don't have to have 2 coils. A system with 2 coils is the most versatile. Okay. It's got the broadest spectrum of energy. If you were to look at if you look at it in terms of light, this would be the whitest white light you could have. The single pin would be kind of a greeny sort of a yellow.
Nice.
Right? Which is a mix of some of the light, but it's missing a whole bunch of the spectrum.
Right.
If you add 1 coil to this, you're going to expand that spectrum, and you're going to have a broader range of light coming out. With the 2 coils, as far as I understand, again, I'm open to correction. I'm always willing to learn new things. But with the 2 coils, what I understand is that's going to be the broadest spectrum. So it'll be useful for as many things as you can imagine, from energizing water to talking to your dog. I don't believe these are just for healing. I think the healing works really good because there's a very strong emotional component to healing. So it's a natural progression for us to take something like this and be able to direct that very strong emotion. But if you can generate an emotional feeling for a glass of water, you can use this device to inject that feeling into the water.
Nice.
or if you can come up with an emotional basis for moving pepper on a bowl of water, you can probably use it and move pepper around.
I got to tell you
Try it.
something really cool. It wasn't just a healing pen, but I won $100 in the lottery today.
Oh, cool.
Yeah. And I think it's because I've been practicing just opening up to the universal energy flowing through me. And, you know, one of my friends always says, oh, you got to see what the numbers are. And my other friend and I decided it doesn't matter what the numbers are. If we're open to the energy of the universe flowing through us and to us, it's going to open up those doors. So,
Sure. And there's probably a reason for that $100 that is necessary
yes,
for you for the
yes.
next step. Who knows? Like, who knows?
It already is.
Okay,
I already know what it is. Yep.
onward and upward. Now, what I'm going to be using for the next stage of this is, again, all of this is variable. You can use it, you can use whatever material you have at hand. The stuff I use is very, very specific. It's not necessary, but I'll explain how to select it, how to select the different elements so that when you go to make these things, it works. The outside coils I make from a fine wire. This is, you know, you can see how fine that wire is. This is 22 gauge and it comes from computer network cable. And when you take the network cable apart, you will have 4 pairs of twisted pairs like this. Oh, you can't see that at all. There we go. Why am I losing my camera? Come on, you can do it. There we go. You'll have 4 twisted pairs like this. And you take that apart, you take the insulation off. This insulation comes off really, really easy. But this is beautiful wire to work with. It's very small. For people with little fingers or not very strong hands, this is amazing stuff to work with. So when you get it done, you have this very, very fine wire. And I'm just going to snip that off instead of trying to straighten it up. Now, your outside coils, you can make them on anything. Like I was saying, you can wrap it around a nail, you can wrap it around a pencil, crochet hook, knitting needles. It doesn't really matter. If you have a selection of knitting needles, you're laughing because you've got a whole bunch of different mandrels you can work with. For the 2 coils, you want a little tiny bit of space between them. You want a little bit of space between the inside coil and your pin, so they're not tight, hard, squashed down onto your pin. And the outside coil, you want a little bit of space around that. So the way I do that is I'll take a device. This is a pretty specialized device. It's called a dial caliper.
Wow.
And I'll measure my wire. And this wire measures 20 thousandths of an inch, 0.02 inches.
Wow. I didn't even know you could do that.
Yeah, well, when I was doing the tool and die work, I was working regularly in 4 decimals.
Wow.
Okay, this measures to 3 decimals.
Nice.
And that's, you can see, I don't know if you can see on the dial, that reads 20.
We can't see. It's a little bit blown out. Let me see if I make you no, it's still,
Well,
it's a little
0.
easier to see when you're smaller, when it's small,
Okay.
smaller.
There's 0.
Yep.
And there's 20.
Nice.
Okay. So it's 20 thousandths of an inch. So on a coil, we'll have one of those on each side. So we have 0.04 inches of wire space that we need to take up. This wire, the pin wire, is 62 thousandths.
Wow.
Plus 40 is going to give us 102. Okay. So if we were to wrap that wire, the small wire, tightly around this pin and measure it again, it would measure 100 thousandths of an inch. But we want a little bit of space.
Cool.
So what we want is a mandrel or a form that's a little bit bigger than our pin. Now you can do it. You can just hold it up next to it. If it's a little bit bigger, it'll work. But
right.
I'm going through the measurement process so everybody understands how to actually think about the math to do this. Now, I have 2 pins here that I've used on a number of things, and they work really well. This one, my smaller pin, is 1/8 of an inch, 125.
Nice.
Okay, 0.125. So I know the wire and my inner pin together makes 102. This mandrel is 125. So I've got lots of space. Okay, I've got about 0.03 on each side of the inside coil, between the coil and the inside pin, which is
Nice.
beautiful.
And are
Nice
you
spot.
using the same kind of wire for both same size wire for both coils, John?
Yes, I am. I
Okay.
will be on this one.
Okay.
I don't see it as necessary as long as the
Mhm.
fit is
And
right.
again, you
It,
said this is insulated computer wire, right?
well, this used to be network cable,
Right.
okay, which has 8 wires inside of it. It's really easy to work with. It's really easy to strip. It's just a bit of a pain to unwind it
What
all
does it
because it's all
look
twisted.
like when it is like coated?
It's blue. It's well, you can get blue or white or orange or whatever else, but it's the round cable that you would plug into the back of your computer for your computer network.
Okay, cool.
Okay, it's got the big
I think I
flat.
can find some of that at the thrift store maybe.
Oh yeah, that's it's everywhere. You can get it easily.
Right.
Now the relationship between the inner and the outer coils, you use the same process. The mandrel that I'm using for my inside coil is 0.125. I know my wire is zero point 0.2 twice, so 4.4. So 0.125 plus 4, we got 10, 20, 30, 40, gives me 165, or 0.165. That's going to be the outside diameter of my inner coil. So I need a little,
I like the visual method, but this is awesome for people that can
okay,
measure, getting what the measurements are too.
yep. And I'll show you when I wind them. I'll show you what I'm talking about. So my outside mandrel, the piece that I'm going to be winding my outside coil, needs to be larger than 0.165. I use 3/16, which is 0.187. So that gives me just a little tiny bit of space between the inside coil and the outside coil. This is how you select it to make sure that your mandrel diameters are sufficient. Okay, so you take whatever size your inner mandrel is plus twice the wire. Make sure your outer mandrel is a little bit bigger than that.
Nice.
That's really all I'm describing.
Cool.
I'm just doing it in a very technical way.
Yeah.
Okay, so we know these mandrels 1/8 and 3/16 with 20 thou wire and 14 gauge will work. We know the
And where did
sizes
you
fit.
get those? What are those?
These are just round steel, round stock I got from Canadian Tire.
Okay.
If you
That's
go to the
helpful.
tool section, they'll have a rack of metals and they'll have different sizes of metals, little round stocks. You can buy them 3 foot length, 3 foot
Nice.
lengths. I cut these down just for demonstration because this camera won't show a 3 foot length sticking out of a drill very easily.
Nice.
Now to wind the coils, you can either just take the wire and wrap it around the mandrel or a pencil or a knitting needle or whatever you want. I kind of go a different route because I love to live dangerously.
A knitting needle's a great idea because they already are numbered. You know, they're already lined up with different measurements.
Yeah, and it might turn out, I don't know the numbers exactly, but it might turn out that a number 4 and a number 7
Right.
would be perfect for what you're
Yeah.
doing.
Yeah.
And the size increments are the size increments between them are very, very small.
Right.
So you can hit the two that are just right
Yeah, that's a great
and
idea.
not
I
worry
like
about
that.
that at all.
That's an
Okay.
everyday pedestrian thing that,
Yeah.
somebody could get almost anywhere.
And if anybody's ever, I'm sure there's some of these folks out there that have followed some of my work with MIP Peru. They know I am a scrounge expert. Everything that I teach, everything that I show how to do, pretty much you can get from just digging around in the trash
Nice.
and get whatever you need locally. It doesn't have to be high tech. You don't have to go and spend huge amounts of money on this stuff. You can do it simple, easy with, I love repurposing things.
I think those are really important points, especially in this culture we're living in where, I mean, not every country has too much, but there are, a number of modern countries where we're throwing away so much right now. As you said, these things should be
Yeah.
pretty available in just
Yeah.
cast off
And
stuff.
Yeah, none of this is, well, it is really high tech, but none of it needs to be built high tech.
Right.
That makes sense?
Yes. Simple.
Okay, good. Okay, so I'm going to wind the small coil first, and I use a drill to do this, variable speed reversible drill. This is my drill, and they're cheap. This was like 20 bucks at Canadian Tire.
Nice.
And
Okay.
it's a great drill. I don't use cordless tools because I know they fall apart really, really fast.
Right.
And this has what's called a keyless chuck. So you just turn it, and if you notice those jaws, you change the size. That's how you tighten things up in there.
Nice.
Very convenient. So I'll take the small mandrel and I'll put it in the drill,
Yep.
and I'll tighten that chuck down. So that's in there just like you would have a regular drill. Now, when I wind my coils, what I do is I'll take the end of the wire and about a centimeter, maybe a half an inch, I'll bend a little 90 in there. Just bend it over so that it's just 90 degrees.
That's helpful.
And what that does is it allows me to slip that wire into the chuck right next to the mandrel. And that gives a way to drive that wire, or to hang on to the end of the wire until some of the coil is established. Because once you get 3 or 4 wraps around your mandrel, it's going to hang on all by itself.
And I found, even as really a novice, and I have used drills a little bit in my life, but I'm not like any kind of expert with them. Following your instructions, this was really easy, even for me to do.
Yeah, it is pretty easy. The first time around, it's going to seem a little scary.
Yeah.
Take your time, go slow. Once you have the core functionality of this done once, you'll realize, yeah, this is a piece of cake, and you'll be able to do it with your eyes closed.
Yeah.
So now there's been debate about left hand, right hand, clockwise, counterclockwise. I try not to use those terms because they're very confusing. It
They
depends
are.
on what school you went to, whether a coil is counterclockwise or clockwise. Some
Yeah.
people look at how it's turned. Some people look at, if you follow the wire, if it's
Right.
clockwise or counterclockwise. Impossible to keep all that straight. So what I do is I wind my coils so they match a wood screw. So the helix travels down the coil the same as a wood screw. Okay? The
And you're
easiest way to
basically
do that,
going in a forward motion with the drill, right?
no,
No.
it depends on what direction your coil is growing from. If it's growing from this end towards the drill, then your drill runs forward. If it's going from this end away from the drill, then your drill runs in reverse.
Okay.
Okay? But for this process, if you're using a drill, run the drill in reverse
Okay.
when you make your coil.
Wow.
Okay?
Cool.
I can't get any simpler than that.
Yep.
But it really doesn't matter as long as the both coils are the same.
Nice.
So if you forget and you wind it the other way, don't worry about it. Just wind your other coil the same. And that system will work just fine because the plasma doesn't care.
Nice.
But if you have one coil going one way, one coil going the other way, what you're winding up with is like 2 streams of water running into each other.
Mm-hmm.
It creates a blockage in the flow of that plasma.
Yeah.
So just keep your coils both the same, and you'll be doing fine. I do it so that it matches a wood screw, just so that people look at that and they recognize it immediately. They don't have to look at it and go, well, why did you do this backwards? And then I have to explain stuff. If I just do it the way they expect to see it, I know it's going to work, and it eliminates a whole bunch of questions.
Cool.
So, okay, to the actual fun part of this. Now, I hope this is big enough, and I hope that's clear enough. My little window is really tiny, so I can't see if it's even focused or not.
We can see it. It looks good.
But you slip the wire into between 2 of the jaws of the chuck, so it's up nice and tight. And then very, very gently start the drill so it just turns a little tiny bit, just to establish how that wire is going to turn. And let it make sure that it's got a bite and it's actually hanging on. Once you have a coil or 2 on there, you want to hold the wire. If you've done crocheting or knitting, you know about holding on to the yarn to add tension to the yarn.
Yep.
But you don't want it wrapped around your finger,
Right.
because the wire will cut your finger and it's very painful and it's not fun and you won't do it again.
Yep.
All you need to do is have one finger on one side of the mandrel, kind of pressed into the mandrel so it's running on your finger, and the other one holding onto the wire, just guiding the wire. Okay. And it's a good idea to have, try to get at least 2 or 3 points of contact while you're doing this. That's the most stable way to do it. And once you get a couple, you can see I've got 3 turns on there right now. Once you have a couple of turns, the wire will actually push, if this finger as up against the coil, it'll actually push your finger down the mandrel. So it will automatically make a really nice tight coil.
Nice.
Okay. Now I'm going to make this about half the length, maybe a little more than half the length of my my pin. Let's go a little farther than that. Okay. Now, how long is that from, compared to my pin? That's about 3/5. Let's go a little farther. If you do stop, remember your coil is gonna loosen up a little bit and it's gonna spring this way. So you want to put the tension back on the wire and push back to tighten that. See how that springs like that? Tighten that coil back up again, and then when you start winding, it stays nice and tight. So let's go about that long, and that should be, yeah, it's about 3/4. So
And gently and being careful of fingers.
yeah, don't let the wire wrap around anything.
Yeah.
That's the biggest point. Stretch your wire out, make sure it's got a place to go and a place that it can flow in smoothly. And as it's flowing through your fingers, as long as it doesn't wrap around anything, you're fine.
Yeah.
It's really rare you're going to have an issue with it, especially with this size of mandrel. You can't really get your thumb stuck in there and wrap your thumb around the coil. But for some of the bigger ones, that's quite possible. Okay, so now we'll cut this wire off. We'll leave again about maybe 1/2 inch, maybe a little bit more on the end of the wire, and we'll slip the coil off, and there we go. There we have our coil. Now we'll do the larger coil exactly the same way. So we take the small mandrel out. Where'd my big one go? There it is. Put the larger mandrel in and get my wire. Where's the end of the wire? There's the end of the wire. Okay, no, that'll work. Make sure it's not hung up on anything. It's not going to drag the dog across the road or get hung up on a cord or anything. Put my bend in the end, slip it into the chuck, and wind my coil.
Nice.
I'm kind of looking at this. I want them sort of the same length. They don't have to be perfect, but I'm a little anal about that, so I'm going to make them as close to the same as I can get. A couple more turns. Now, for your information, the amount of wire I use for these 2 coils is about 10 feet. And I have 2 inches left over.
Wow.
So I
Perfect.
really lucked out. I guessed almost exactly.
Perfect.
And this one you want, about the same amount. So about a 1/2 inch, maybe a little more.
Nice.
On each end. And there's your 2 coils.
Nice.
It's that easy. And I'm serious. It is that easy. Once you get used to this, it goes so fast. Okay, that's it for the power tools. We don't need them anymore. Put that away. Now we're going to start with the smaller coil. And I'm going to start with the end. Is if you notice, one end is the wire comes out at a tangent to the coil. The other end, it comes out parallel to the coil. So I'm going to start with the end that comes out a tangent to the coil, and I'm going to very, very carefully grab the end of this piece of wire, and I'm going to pull it in so that it almost crosses the center of the diameter of the coil. And the reason for that is when I put the pin in there, it helps me center the coil around the pin. Okay, now if you notice my mandrel selection, I've got a pretty good amount of space there.
Nice.
I don't know how well you can see that, but
Yep, we can see it.
that's
So
what you want.
JC, can you show us again which end you put that into? Show us that end without the pin in it. So
Well, I started, oh,
it's
the end,
really the counterclockwise end, right? Or
well, it goes this way.
right.
If
Yeah.
you were to follow that
Oh,
wire down the loop, it's going in this direction.
okay, never mind.
Okay, but it doesn't matter as long as they're both the same.
Right.
Okay, the end I used was the end of the wire where I finished the coil. When it
Okay.
came off at 90 degrees to the coil. Okay, just because it's easier. This one is very difficult to manipulate and get that bent
Okay.
around so that it's ready to wrap around the
So
around
this
the
one's
pin.
bent in so you can kind of stop the pin with it
Yeah,
or
and
center the pin with it.
I start by I show this. There's a very clear picture of this in the PDF. So when you look at the PDF, you'll understand it a little better. But I bend that wire in towards the
Raise it
center of
out
the
away
coil.
from you just a tiny bit. You're almost there. You are. You're almost off that. There. That's good.
Okay. Yeah. Well, I'm gonna adjust that just
There
a
you
little
go.
bit because
Yep.
it's uncomfortable. Okay. So the little tail that comes off the coil, I push it in towards the center a little bit to get started when I go to wrap it around the pin.
Nice.
And then I slide the pin through the coil.
Yep.
And this is the little trick. This is the part that you had the real problems with, Carrie.
Yep. I had.
And you need the needle nose pliers and very fine. Like you notice these are quite small. These are very fine needle nose pliers.
Yep.
And it's helpful when you're working with thin wire like this to have really fine tools. Grab the wire and your pin at the same place so that you're holding it nice and tight. And there is a trick to this. I can't really describe it. It's just something you have to do. And it's not easy. Believe me, it's once you get it, you're going to be really happy. But
You're
the
really
idea
close.
is,
You're almost off the edge again. If you can adjust a little bit.
yeah, I'm trying to watch what I'm doing and
Right.
watch the
Gotcha.
computer as well. But the idea is to get a hold of that wire so that when you start wrapping it, you don't distort the coil. And I noticed with yours, I've seen that a couple of times. Actually, what I'm going to do,
Yeah, actually, yeah, I definitely distorted the coil then. And I was pulling my coils apart too. So yeah, I was messing with them. So yeah, it's helpful to see you show us how to do this properly.
I'll show you that. So what I did, I pulled that wire out so it's not actually 90 degrees. It's kind of pointed up a little bit,
Yep.
which will allow me to grab that with the needle nose. So I'm grabbing both pieces of wire, both the pin and the little bitty wire with the needle nose pliers. So I'm anchoring that down.
Off
And then
screen.
following
Off
the same direction that it's wound in, there we go,
Cool.
wrap that neatly around your pin.
Oh, look how handy that is. Aren't you smart?
Okay. And that doesn't mess up your coils. Your coils stay nice and
Oh,
smooth.
nice.
And it doesn't matter if there's some randomness in your coils, it adds randomness to the energy.
Yeah.
Which is not necessarily a bad thing.
Right.
Now you're going to have a little bitty end. Actually, I did that wrong. I'm going to have to back up a little bit. You're going to have the end of the wire is going to eventually be sticking out. I didn't make these quite long enough. So go a little more than a half an inch. Where's the end of that? If you have to unwind it, try to catch the end with your fingernail.
You're off
And
screen.
that way you can unwind it. There we go. Okay.
Off
So
screen.
before you wind it up really, really tight, put a couple of loops around. It's going to be hard to see. I've got 2 loops on there. But the same as you did with this wire, you want to do it with the end of your coil wire.
Oh.
Okay, you want to loop it back on itself.
Ah.
and then snug it down nice and tight and sort of tuck it in there so that it's out of the way. Okay, that way any energy that's flowing down that coil wire doesn't just squirt out the end of the wire, it gets directed back. Okay?
Cool.
And then however you want to tuck it down is up to you. I try to get it tight and then I fold it so that it's parallel.
Nice.
There we go. And that's very, very tiny and really hard to see, but if you zoom in with a good resolution, you'll be able to see it.
Cool. Get it up in the screen a little better. There you go. Yep.
Well, I'm looking right here at this end, and I'm
Yep.
dead center of where I'm looking at.
Awesome.
So,
Yep.
but it's, the wire comes in, wraps around the inside pin twice, gets folded back on itself, and then it's pressed down in so it's nice and tight against that pin.
Nice.
Now the other end, you want a little bit of space along this coil, so grab that wire and just give it just a little bit of a tug. You don't have to pull very hard,
Nice.
and do it little bits at a time. Because if you just grab it and yank it, you can go way too far, really, really easy. But just sort of tug on it,
stretch it
a
out
little
a little
bit.
bit.
Stretch it out so you have just a little bit of space in there.
Cool.
And then do the same thing on the other end.
Nice.
You want to take that last loop, grab it with the needle nose, squash that loop down tight, wrap the wire, and put a loop on the end of that wire.
Nice.
Okay, and we'll put a loop on the end. Just like that, and then push that loop down tight, just like that.
Cool.
Now, if you notice, my pin on this end is off center. Okay, it's stuck to one side of that the coil.
Right.
So what I do is I'll just use the needle nose pliers to very gently grab on one side the pin and the coil, the last loop on the other side, and just squeeze a little tiny bit, which pushes that coil so that it's a little more centered.
Come back on screen for us. There you
There
go.
we go. And I'll just grab the last little coil and just sort of push it sideways a little bit, just so that it's more or less in the center. It doesn't have to be perfect, but
Nice.
make it look nice.
Awesome.
Try to be as nice as you can with that.
You're a great person to model.
Now, the outside coil is the same thing. You do exactly the same thing with the outside coil. It's just a little bit trickier because you've got the inside coil. You don't really want to mess it up. So we'll take the larger coil and we'll move that last loop a little bit so that you've got a tight curve right near the center. But it needs to be big enough that everything can still go through. And then you feed your system through the outside coil.
And you're putting it through so the ends are going the same direction, right?
Well, they're going to go the same direction just because that's how you wound it.
Yeah.
They have to. There's no way you can reverse it.
Okay.
Okay. So you put your outer coil around the inside coil. Try to go past the end of the inside coil just a little tiny bit so that you don't actually squish that inside coil. And then do the same thing. Wrap that wire around your pin and put a little loop on the end of it. Okay. Come on, you can do it. I just got to get a hold of it. There we go. There we go. Wrap that around, and it's useful if this goes beyond where you wrapped the inside coil, so it's actually around the outside lengthwise as well as around the outside edge.
Nice.
And loop your end, and then pull that in nice and tight to control it. And do that same thing to the other end.
Nice.
Now, give that a stretch. Come on, come on.
Yeah, it's really helpful to watch this because I think I was trying to pull mine too far apart, and just really.
Yeah, well, I did this one kind of quick, so I made a few mistakes with this particular one, but they're not mistakes, they're just inconveniences.
Yeah, but you're pulling it apart more gently than I was, so that's really good to see. Good to just see the,
Yeah.
you know, good way of doing it.
Okay, so I need to, because my inside coil is a little bit too long and it doesn't want to stay out of the way.
Kind of losing the point of your pen a little bit.
Okay, grab onto that. Wrap it.
Now, are you going to bend both ends inward?
Loop it. And squeeze that down so that it's not sticking out.
So
well, it's just
both ends of that wire are going to be kind of pointing back in rather than one of them pointing out with the point of the pin.
Yeah.
Okay.
They feed any energy that flows down that coil gets fed back into itself.
Okay.
Because you got to remember, you're not working with the copper itself. You're working with a flow of energy, which is going to be in the nano coating, not in the copper.
Got
Once you coat this, the copper is just a structure.
Okay.
It's not really doing anything. But there's essentially a completed coil, a completed pin. Clean up the ends a little bit so that it looks nice.
Beautiful, beautiful, beautiful.
And straighten things out. And there you go. That's basically it.
That's gorgeous. And some of the ones, like I remember watching one of the guys from the Philippines, he had actually made an outer layer that was more of an egg shaped, like he had experimented with a couple of different shapes on the outside. Do you think that was outside these two coils, or was just the second coil shaped differently?
It's the second coil.
The second coil. Okay.
What they're looking for, if I understood Renan properly, what they're looking for is specific effect.
Right.
They're adjusting their coils so that they're also adjusting the kind of fields that they emit for very specific effect.
Right.
Their criteria, I don't know, but that seems to be what they're doing.
Cool. So the next step with this would be to nano coat it. And rather than us going into all the instructions on that right now, let's just give a short, basically, we're going to expand the outer molecules by a treatment with caustic or heat, correct?
That's right.
And that we'll put a video below this video that gives instructions on how to do it with caustic, which is kind of the original method that we were taught. Correct?
Yeah, Armin has a video. It's on the Keshe Foundation website. If you scroll down near the bottom of the page, there's a series of links on the bottom of the page, and there'll be Armin's nano coating.
It's great. It's very simple. It's easy to do. I've done my nano coating based on that, and very helpful. And there's a lot of other interesting nuances that are coming in. But if somebody will start with that, it's just a good place to start.
Yeah, and you know, again, this is the bare bones basic. You know, if you're learning to drive a car, you don't learn brake slide parallel parking first.
Right. So yeah, like my dad always told me, learn how to drive a stick and you'll always be able to drive anything, right? Learn how to do it right.
If you start with the basics.
Start with the basics.
You know, like if you're learning to drive a standard transmission, the way I taught my stepdaughter was, the first thing I taught her to do was control the gas pedal. So I had her sit there, car was running, okay, step on the gas pedal, bring that needle up to the 2 and hold it there. Okay, and once she got that, okay, now bring it up to the 2.5 and hold it there. And I taught her how to control the gas pedal. The next thing I taught her was where the clutch was. So put it in gear, Slowly bring that pen load until you feel it in the car, because you'll feel it in your hands, you'll feel it in your butt. Learn where that spot is.
Nice.
Okay. Now I want you to put a little bit of pressure on, or, a little bit farther. So you're putting a little more pressure on the clutch, and watch that needle. And it dropped way down. And she's like, oh no. And she stepped on the clutch. And okay, awesome. What I want you to do is I want you to put the pressure on the clutch and use the other foot to hold that needle at 1,000, at the 1. And I taught her to do that, and the car started to move, and she went, oh, this is cool. She only stalled the car once.
Nice. So I think that's a really good point. Yep, doing the basic nano coding that has been taught by the Keshe Institute is a really good way to start. You get what you're doing. The first bath is for really cleaning the copper, and then the second two are for expanding the molecules. So
yeah,
is that right?
And making GaNS, it's the same thing.
Yeah.
Don't start going, like you can look on the net and see people using seawater and electricity and shining a laser at it and dancing naked and whatever else. Start with the basics.
Right.
Get down what we know works, and then if you want to add complexity, do it one bit at a time.
Right. So once this pen that you've just made has been nano coated, the coils with the pin through the middle,
Yep.
then it will dry out, and then it will go into a plastic shell, right? A plastic cake.
Yep.
And so
yep. Once you've nano coated it, it's very important. Don't touch it with your skin at that point.
That is really important to remember. So rubber gloves, basically, right? Or
it's not a health issue.
Right.
It's a functional issue. If you apply your DNA to the pen, it's going to emit whatever condition you have. It's going to tune itself to your condition at that moment.
Wow.
So don't touch it with your fingers.
So what would you use rubber gloves to touch it, or
yes.
Pinchers, or?
Yes, I use the blue nitrile surgical gloves.
Okay, and so rubber gloves, only picking it up with that, and then it goes inside of a plastic sheath of some sort, right?
Yeah, you can use aquarium tubing if it's small. You can get vinyl tubing, lengths of vinyl tubing. You can use hard plastic. What I did for my first batch was I went to the dollar store and I bought a $1 4-pack of dry erase markers. The black, it's got a black end and a white handle on it. They're just black dry erase markers.
Yep.
Pop them apart, take the guts out, put the pen inside. What I did was I took a little piece of the insulation that I took off of the wire itself.
Right.
And on the end of the pin, on the end of the health pen, I pushed that wire back on. And then I took a lighter and heated up the end of the wire so it was starting to burn, and squashed it into a point.
Nice. So the thing
which makes a really nice little round end on it, and it protects the end so you can't actually touch anybody with it.
So the metal isn't even sticking out at all on that, right?
No, the only thing you see is the end of that piece of plastic.
Oh, cool.
And that is just the right size. Brilliant. With 14 gauge wire, just the right size to fit through the hole in the end of a dry erase marker.
Awesome. And is the dry erase marker metal or plastic?
No, it's plastic.
Plastic. Okay. So you want it
and
to be...
I took the pen, I took the nano coated pen, the metal part, slipped it into the business end of the dry erase marker, the black part. I don't, because there's going to be different colors, I assume, but where the tip used to be,
right,
slipped it through so that it stuck out a little bit. Then took some silicone sealant, just aquarium silicone, fast drying stuff. Squirted a bunch around the end of that and stuffed the end of the pen back on.
Smart.
And that solidified everything inside the pen so that it wasn't bouncing around, it couldn't move. I still took it apart, but when I did, this one that I took apart, and it just absolutely destroyed itself. Because the silicone was all holding it. It got right in there and it was all holding it together. And when I took the pen apart, it just ripped the coils right out.
Wow.
So I know it works. We know silicone doesn't affect any of this stuff. It's pretty much inert. So it's
Right.
easy to use. You can seal up all kinds of stuff with it. But
So let me
that was the simplest way I found to do it.
That's awesome, JC. I love it and really helpful. So the idea is the end result needs to be encased in plastic so that it's never touched by anyone, and it's basically funneling in energy and pouring it out in a certain direction.
Yep. And when you hold on to it, you hold on to it by the end. Don't hold it like a pen.
Right.
Well, I suppose you could, but because of the flow, the way the energy flows, I think you want to hang on to it more like a stylus,
Like a wand or a stylus,
like
right?
a wand.
Mm-hmm.
Yeah. And work that way, because then your energy is coming into one end and working its way to the other end.
That's maybe where magicians' wands came from. Maybe the ETs or the other dimensional beings came here and knew how to do this, and they had magic wands. Let me just show this really quick, because I basically just did this with a screwdriver and just took it and wrapped it. It's not quite as tight. It's a little harder to get it as tight, but I think with a little practice, I'm just basically running the copper wire around it, and
Yep.
I just made a couple by hand. The reason mine were so rough is because I kind of messed with them a lot. And like you said, it was when I was trying to tighten up the ends. But
Yeah.
this just makes a really nice coil. I guess, can you see that?
Yep.
And
Oh yeah. And
and
you
go,
can also put that screwdriver in your drill.
oh yeah, that's a great idea. Would you put a knitting needle in your drill? They're plastic. Yeah,
A metal
metal.
one you can do.
A metal one, yeah. So,
Yeah, a plastic one will
oh,
just
you
break off.
could
But
put this in your drill, couldn't you? But I
yeah,
mean, if somebody didn't even have a drill, it doesn't have to prevent you from making this. You know, the drill is a
that's right.
really wonderful way to make it very perfect. And my wire that I'm using right now is a little short. I should have had a longer piece. But
It's pretty heavy wire too.
yeah. But anyway, this just shows how easily you can wrap one of these and make them at home. I've got a few little loose I just want to encourage people to don't let not having things stop you, you know. So there's a really nice, uh, a
Yeah,
really,
that looks awesome. And a
yeah,
little bit of randomness isn't going to hurt anything.
right. It just
Mike
helps.
Nashif mentions that. He says, don't worry about making it perfect. If it's got some human randomness, that is actually probably going to make things better,
Cool.
because it adds some randomness to the plasma energy.
Right. So, I mean, it's so simple. But what I wanted to do with the beginning of this discussion was to help people get an idea of what we're really doing here, what this energy is about, how it works, what we're learning to relate to, and then the practicalities of making these things. I would say there's an old saying that says, the things that are really wise confound the simple. I mean, it's almost confounding how simple this is, and that we can really pull in energy this way. So it's a whole new thing for us to relate to. But I encourage people to start experimenting at home, because these healing pens are something you can make yourself, and or get some, start playing with some friends, make them together. And why don't you hold yours up, John? Because yours is so nice and neat. Mine's just a little practice coil made with a screwdriver. But yeah, look at how cool that is, and awesome.
And it's very, very simple. And the other one I did, this uses just 14 gauge wire. And so you don't really, that's in the shadow.
Yeah, we
There we
can
go.
see it. Yep.
And so the size of the wire really doesn't matter. This is just a single coil. So this is, I would say this is a mid-range power. And you notice I got lots of pins sticking out each end. I
Yep.
didn't stretch it very much. All of this, try it. We
Yes.
don't know where the limits are.
Yeah.
So if you have an idea, if you have an intuition about something and you're
Yes.
building it and you get a little picture in your head, just do it.
Mm-hmm. We've
Try
got
it and see what happens.
Absolutely. And we're seeing that with these people all around the world who are putting these things into practice. And you're seeing from all these different cultures and people who have minds that are doing different things, all kinds of neat things are emerging. But follow the
Yep.
basics. There's certain basic principles that I think, JC, you covered extremely well, and I'm very appreciative of that. Your kind of scientific, kind of sequential mind. It's really, really helpful to get to see it that way and give people those
Yeah.
basics so that they can start there and then they can experiment out from that.
Yeah, and the fuel to drive these devices is emotion.
I'm just getting
And
chills just talking about this.
I'm not talking about weepy, cryy, tears down the eyes, giggling your face off kind of emotion. I'm talking about just the feeling of well-being. It's a very subtle thing. It's not the gross, in-your-face emotion that everybody is familiar with. It's the the feeling you get when you walk into a beautiful park,
Mm,
or when you see someone that you haven't seen in a long time. That
mhm.
initial little spark that makes your heart jump.
Yeah.
That's the kind of emotion that I'm talking about.
Yep.
And that's the fuel for these devices.
And
That's what makes
yep. I call it like a sense of knowing that we're one with source, that we're part of this source field and it can flow through us. And I'm getting chills even just talking about that because it's such a cool, it's been a practice in my life, and it's part of the 21st century superhuman meditation to just merge with that on a daily basis and see our lives emerge from that source field.
Yeah. And one of the things when I first started getting into this, I was trained over 30 years of what I thought at the time was a really sucky life to be detached and cold and kind of step back and not really emote, not really show feelings. But I realized that doesn't matter, because I still get, when I walk in, I see an amazing flower. I see an orchid that I've never seen before. I get that feeling in my center. So I know it's still there. Everybody has it. I just
Nice.
have been trained not to be overly outward with it.
Right. I'm just getting
Uh,
chills as you're talking about it, though. This is getting in touch with this amazing life that we're part of. And
yeah,
I think this Keshe energy is teaching us that, the plasma energy. It's beautiful.
yeah. Oh, I'm not sure if we discussed it in the recording, but I know we talked about it earlier. One of the reasons for the devices is to teach us that we don't need the devices.
Yeah.
And as soon as somebody makes one of these and starts using it and recognizes the energy that they're working with, they don't need the device anymore. They can do
Right.
it with their finger.
Yeah. Okay. I think we better go. And
All right.
I think we've been a couple hours and it's probably good. So thank you so, so much for your time. I think we should do a few more of these and keep building on this information that people can kind of get a step-by-step elementary understanding of this new science and start implementing it around the world, because that's what this is about.
All right.
All
Well,
right.
I'm happy to share, and I hope whoever's building these things, if they had questions, they have fewer questions now.
Yeah, me too. All right. Many blessings to everybody. We'll see you soon on the next 21st Century Superhuman show. Much love.
Bye bye, everybody.
Adios.